Business Finance Chapter 4. In Chapter 4, we talk about time value of money. So we look at the present value amount, which is the current value of future cash flows discounted at the appropriate discount rate, and the future value, which is the amount an investment is worth after a time period of earning interest or later money on a timeline. Now, both present value and future value operate under the assumption that any money you have would be invested and earning interest as part of these calculations. The theory behind time value of money is that a dollar earned today is worth more than a dollar given to you at a future time, because I can take a dollar today and invest it, and then it would be worth more to me in the future. When we're looking at interest rates, other terms for an interest rate are discount rate, cost of capital, opportunity cost of capital, required return, required rate of return, a hurdle rate. The terminology depends on the usage. We will talk about all of these during various parts of the chapter. I will probably use hurdle rate most often when I'm talking about the interest rate. Discount rate is also commonly used, especially when we're talking about capital budgeting in a later chapter. When we're talking about the cash flows, we need to think about the timing of cash flows. In most instances, we start with time zero, which is today. That is generally the first cash flow, and then we earn a rate over different times. So time 1 is the end of period 1, 2 the end of period 2, and 3 the end of period 3. Plus cash CF equals a positive cash inflow, negative CF equals a negative cash outflow, and PMT equals a constant cash flow or a regular payment. PMT is usually used as an abbreviation of the word payment, indicating that something happens at a regular time. And we're going to start looking at some examples of how this works in calculations. So we have a timeline for a $100 lump sum due at the end of year 2. So we have 0 right now, and in year 2 we're going to get $100. So we can see that that timeline would be 0, which is right now, 1, which is the end of year 2, and 2, which is the end of year 2. The general formula for future value equals the present value times 1 plus the interest rate to the number of periods. So T as the number of periods. So the future value interest factor equals 1 plus the rate to a time. The YX key on your calculator if you are using a financial calculator. There is a presentation for the formulas exactly as they get entered into the financial formula in My.Warburg, and they go through step by step on how to use a financial calculator for these calculations. For this class, during class calculations, we won't be using a financial calculator. We'll be using Excel and math formulas in order to calculate them. So we have this example. So suppose we invest $100 for 1 year at 10% per year. What is the future value of that $100? Well, we have interest. We have one time period, just 1 year. So the interest is $10, 10% of $100. So the value in 1 year is principal plus interest, or 1 plus 10, $110. When we put that into the future value calculation, we see the present value is present value PV 100. 1 plus the rate, shown as a decimal, 0.10 for 10%. And there is no to the time because it's only for one time period. When we extend that to 2 time periods here, we can see that we've added the time 2 for the formula. So if we leave the money for a second year, then the future value of that $100 at 10% interest is $121. And that is 2 years of interest accumulation. We have different kinds of interest. Simple interest is interest earned only on the original principal. Compound interest is interest earned on principal and on interest received, or interest on interest. So in an example of compound interest, if we're talking about the $100, we would have $100 plus 1 year of interest of $10. That gives us $110. Principal plus interest. In year 2, when we earn interest, we earn that interest amount on $110. That is compound interest. We're earning interest on the original interest from year 1. If we had simple interest, then we would just earn $10 a year in interest on that principal amount. You want compounding interest because that gets you a higher amount of interest, instead of earning on the principal of $100, you're now earning, for the second year, you're earning on $110. We can see the effects of compounding when we go back to that previous example. So with simple interest, after 2 years, we have $120. With compound interest, after 2 years, we have $121. That extra dollar comes from the interest earned on the first amount of interest, that $10 from the first year. Compounding interest, the longer you leave something in to earn that interest, can earn a lot of money. So now we're going to look at an example. What if we invest the $100, but we invest it for 5 years? So we put that into our present value formula, our future value formula. Our present value is $100, our rate is 10%, and our time is 5 years. So 1.10 to the 5th power equals 1.6105. We can also use a future value and a present value factor table in order to look at these factors, and we will practice that in class. So after 5 years, we would have $161.05. This slide shows you the Excel formulas for time value of money. The first is the future value. Second is the present value. Then you have the rate. If you don't know what the interest rate is, you can use the amount, or the you can use formula icon FX when you can't remember the exact formula. So this is how you put the formulas into Excel. You need to have the different items, the rate, the number of periods, the payment, and the present or the future value of the amount set up in different columns. We will practice this in the chapter for examples when we're using Excel. Suppose we had a relative deposit $10 at 5.5% interest 200 years ago, and we just found out about this account and we go to look for it. So how much would that $10 be worth 200 years later? Well, we have the calculations. If we use the written formula, that $10 times 1 plus 5.5% interest to 200 years, time of 200 years. It equals $447,189.84. If we're putting that into a financial calculator, that is how we would input it. And if we're using Excel, we would ask for the future value with the rate, the number of periods, the payment out, they're zero. We aren't taking payments out of it, and the present value is $10. That's what we're putting in. For future value, we can look at the general growth formula. So suppose our company expects to increase unit sales by 15% per year for the next 5 years. If we currently sell 3 million in 1 year, how many would we expect to sell in 5 years? So we're trying to determine what that 15% growth looks like in number of units. So our current amount is 3 million. Our rate is 15%. That's the growth we're looking at per year. And our time period is 5 years. So we can put that into any one of our formulas, either our handwritten formula, our financial calculator formula, or our Excel formula. We get the same result each time, which is 6,006.0341 million widgets. So we would more than double the number of widgets that we want to sell in 5 years if we were looking at a constant 15% growth per year. For any given interest rate, the longer the time period, the higher the future value. As time increases, future value increases. That is the benefit of compounding interest. For the higher the interest rate, the larger the future value. So any given time period, as the rate increases, future value increases. So even if we had a constant rate, if we increase the amount of time, the future value increases. If we have a constant period of time, we have to increase the interest rate in order to increase the future value. Next, we're going to talk about present values. This is the current value of future cash flows discounted at our appropriate discount rate or interest rate. Remember, discount rate and interest rate are the same exact thing. So the value at T is 0 on a timeline. How much do I have to invest today to have some amount in the future? Or what is the current value of an amount to be received in the future? So say you want $1 million to retire in 40 years. How much would you have to put away every single month at a certain amount of interest in order to have $1 million in 40 years? So what is the present value of $1 million? Present value is the current value of an amount to be received in the future. It's worth less than face value because of opportunity cost, risk and uncertainty, and that discount rate takes care of the time and risk. So if I had money now, I could deposit it. But since I'm not going to receive that money for 40 years, there's risk. The interest rate could change. It's not worth as much to me now. When we're looking at the timeline of cash flows for present value, we have year 0, which is today, and then we have each year. R is our rate, plus CF is a cash inflow, negative CF is a cash outflow, and PMT is a constant cash flow that happens on a yearly basis. So that's a payment. That's also called, in the time value of money, that's also called an annuity. That means that you would want to take out a regular amount over a period of time. Right now, we're just looking at single sums. The formula for present values is flipped. So we have the future value equals present value times 1 plus the rate to the time. When we rearrange that equation, then we get that present value equals future value divided by 1 plus the rate to time. Discounting is when we find the present value of one or more future amounts, which is another reason that interest rate is called a discount rate when we're looking at present value. So now we're going to look at a different example with $100. So what's the present value of $100 due in 3 years if we have a rate of 10%? The present value at a rate of 10% equals $75.13. So today, $75.13 has the present value of what $100 would be in 3 years at 10% interest. What if we needed $10,000 in 1 year for the down payment on a new car? If we can earn 7% interest over that 1 year, how much do I need to have available today? Well, for 7% interest, I have to have a lot available today because we have such a short time frame to earn interest. So for the formula, we have the future value, which is $10,000, and our rate of 7% and the time frame of 1 year. That gives us a present value of $9,345.79. We also have the financial calculator input and how we would put it into Excel. Of course, in our examples, we will practice this. If I have multiple periods, so this example is I want to begin saving for a college education, and I estimate that I'm going to need $150,000 in 17 years to pay for 4 years of college. I feel confident that I'm going to get 8% interest, so how much needs to be invested today? Well, to have $150,000 in 17 years at 8% interest, today I need to invest $40,540.34. You can see this through 3 different ways to calculate this formula. So the future value, which is $150,000, divided by 1 plus the rate to the time. In our next example, we have a trust fund, yay, that our parents set up 10 years ago that is now worth $19,671.51. We want to know how much they invested in the first place if the fund has been earning 7% for the last 10 years. The future value, $19,671.51. Our rate, 7%, and the time period, 10 years, gives us a present value of $10,000. That means that 10 years ago, our parents put $10,000 into a fund that earned 7% each year. For any given interest rate, the longer the time period, the lower the present value. So as time increases, the present value decreases, regardless of what the rate is. The present value of $500 to be received in 5 years with a discount rate of 10%. So for 5 years at 10%, the present value is $310.46. If we extend that 500 out to 10 years, then the present value is $192.77. Another present value relationship is that the higher the interest rate, the smaller the present value. So regardless of time frame, if we increase the interest rate, the present value is going to decrease. So we look at this. To find the implied interest rate, we rearrange the basic present value equation and solve for R. So this is if we don't know what the interest rate is, but we know what the amount is for the future value and the present value and the number of time. We can use that to calculate the rate. If we're using formulas with a calculator, we need to use these extra keys. And as I said, the calculator formulas are all included in your textbook. and in the PowerPoint listed in my.workbook. So we're going to look at this calculation for trying to determine the rate. So we're looking at an investment that will pay $1,200 in 5 years if we invest $1,000 today. So what is the implied rate of interest? Well, the future value is $1,200, the present value is $1,000, and the time period is 5 years. So that gives us a rate of 3.7% implied interest. We can also use the rate formula in Excel to calculate that for us, or a calculator equation as shown here. We can also rearrange to find the number of periods. So how many years? So if we know the future value and the present value, we rearrange that to get the time period. Or we can use the number of periods calculation in Excel with the rate, payment, present value, and future value. So we'll look at an example where we calculate the number of periods. So we want to purchase a new car. We're willing to pay $20,000. If we can invest at 10% each year, and I currently have $15,000, how long will it be before I have enough money to pay cash for a $20,000 car? So then I'm trying to determine what the number of periods are. My rate is 10%. Payments are 0. The present value is $15,000, and my future value is $20,000. So in 3.02 years, I will have enough money to pay $20,000 cash if I invest that $15,000 now. This is the end of chapter 4. These time value of money calculations are just best with practice. So we are going to do a lot of examples in class.